So good afternoon everyone. So today we are assembled here for discussing about the case study topic in our subject optical and microwave engineering. Especially nowadays the 5G, right? Fifth generation communication is taking over in all the places, especially in electronic communication systems. Though we have a very wide range of advantages, we have some drawbacks in the 5G communication networks. So the main thing which we are now, as we are studying about the microwave engineering in our this semester. So we have to take this is one of the challenge, and as a student and a faculty member, we have to address this industrial problems. So what's the problem here means? Even the 5G communication have a very good high speed and good connectivity and everything. We have some problem, I told already. The main problem is to eliminate the unwanted signal is the very important thing. So filter out the unwanted signal, because as this microwave signal is propagating through free space, and even if the communication takes place inside satellite also, so it is traveling literally in a very long distance. So filter out the unwanted signal as it is traveling, propagating in the long distance. The external signals will add up with the original one. So at the end, receiving end, probably the mobile phone will take mobile phone which receives only the particular signal, not all the signals. So we need to filter out the unwanted signals. Unwanted signals here, which is addressed as the unrequired signal, right? It's other signal. So filter outing that unwanted signal is a very good biggest drawback. So to eliminate the unwanted signals, we must design the filter appropriately. So filter we know. So filter means that will eliminate the unwanted signal. So in 5G communication, the microwave filter is very important. So we have to design and optimize the filter appropriately. So that is the case study here. This is the industrial problem. So we must address from our side as a student and faculty members. So let me ask you, let us together discuss what are the things we can address, what are the solutions we can give, right? That cumulatively, we can consolidatively, we can give to the industry people. So appropriately they can select anyone, because the economic thing also is there. So that also must be considered. So we can conclude finally. Let us list one by one what are the things is there to rectify this problem. Okay. So let me give this session to your hand. You can tell your opinions.
I would like to share about the design approach in 5G networks. First, a selection of filter types. For this study, a hairpin bandpass filter is used due to its compact size and low insertion loss and high performance in high frequency areas. And choice of substrate impacts the performance of the filters. I would like to share about some key parameters considered. Dielectric constants, it affects the size of the bandpass filters and performance of the filters. And loss agent, it impacts the insertion loss and thickness. It affects the impedance of the matching. Yeah, Rogan 4003C is selected due to its low frequency and low loss of impedance.
So let's talk about the frequency equations, chosen equations. So here we are deriving the filter equations. Here we are deriving the filter size or filter values by using some kind of equation. So here we are using Chebyshev polynomial approximation for finding the filter value. So where the center of frequency is 28 GHz and the frequency bandwidth is 5%, and the order of the frequencies based on the required selectivity. So the next important thing is simulation and optimization. So here we are using HFSS or CSG or Microwave Studio or ASG for our simulation purpose. By these tools, we are able to simulate the electromagnetic waves and we are able to find the S parameter. And also these tools help to achieve understanding the dimensions better.
Now let's see the key performance parameters. So in key performance parameters, there are two losses. One is insertion loss and next is
there are some key like Darshan said, there are some key parameters are there. The first one is insertion loss. So it should be less than 1 decibel. So after that is return loss. So it should be less than 15 decibel. And the bandwidth is, I already said, it should be 5%. So in 20 gigahertz, the 5% is 1.4 gigahertz.
So the next is resultant discussion. So in result, we got the simulation result of the first design device, which shows the insertion loss of 1.2 decibels and the return loss of 12 decibels. So after optimizing the coupling gaps and the line width, we got the insertion loss of 0.8 decibel and the return loss of 18 decibel. So from this, we can create a device which shows the change in the decibels. And as for conclusion, to this case study highlights the difficulty of designing a bandpass filter for 5G communications. So by carefully selecting the appropriate device and optimizing the frequencies, we can build a high power devices.
Yes, okay. So as you said, so many ideas you have proposed, right? So let us have an interaction with the industry people also, and we can come to the conclusion. So that if they are needing some assistance from us, we can go to that industry and we can take this as an opportunity to develop our skill towards this microwave engineering. Okay, thanks for the discussion. Thank you.
Thank you.